this will be my last lesson for this chapter on lenses. Okay, so this is the last part of light that we will cover. So, there are two different kinds of lenses. Converging lenses and diverging lenses. Now, within each of these, there are, of course, different kinds of those types of lenses. So, for example, a converging lens has the rounded middle, so it's thicker in the middle, but it could look different. Like, for example, this could be a straight edge instead of curved, but it's still considered a converging lens. So, for example, a magnifying glass, and like I said, those ones are fatter in the middle. Then diverging lenses have the inside curve, right? So it bends inwards. And so it's thinner in the middle, usually used for eyeglasses to cure myopia, which is nearsightedness, right? So, for example, the glasses I wear, they would be diverging lenses because I'm nearsighted as well. So those are the two different types, like I said. You could also mix the two. So for example, I could have this inside curving in, but then this one curving out. Each different kinds of lens does a different thing. But what we are going to focus on is mostly the converging lenses for this part. Okay? Great. I'm glad you're prepared. So, converging lenses will take parallel rays of light and change them, they converge on a principal focus or focus point. So, you may not be able to see this here, but you have a straight line that goes this way, straight line all the way through, and a straight line going like that. So it takes the parallel rays and bends them in to meet at some focus point. Okay, so that's, for example, with a magnifying glass, if you've ever done this outside, you hold it up and you notice there's one spot that gets hot. You can, burn paper or bugs or whatever tickles your fancy, right? But I don't know if you've ever done that, but that's one example. And it could also take, for example, if these rays are going out here, and then I put another one of these converging lenses afterwards, it will take these these rays, and then they'll be parallel on the other side. Okay, so it works both ways. Any questions so far? Okay. So the fatter the lens, the closer the focus point is. So if the lens in the center gets bigger and bigger, the focal point would be closer and closer to the lens. Okay. So this one, forming a real image. So with these kinds of lenses, you can have real images. So when the sun's rays are focused on a piece of paper, a small image of the sun is created, and the same can be done with a light bulb. This is the idea. I don't know if you've ever made a pinhole camera during an eclipse. You know how you're not supposed to look directly at the eclipse? You make a pinhole camera so the light from the sun gets shine onto the back of it, and then you can actually see the eclipse that way, if you've ever done that. I know I did in grade school. They're kind of fun. David, chair. Thank you. Okay, so you'll notice a few things about the image when you do this. So the image is inverted, so it's upside down. The image is smaller, right? So it's reduced. It's nearer to the lens and real. So I know this is hard to see, but this is a picture taken out of your textbook. We just have a light bulb here. We have our lens. And this is the light bulb turned upside down and a little bit smaller. And this last one, mirror to the lens. If it was something like this, and this is the light bulb, right? The image of the light bulb would be closer to the lens and then upside down. That's what that means. So this would be the bottom here, right? So it's smaller, closer to the lens, and upside down. Okay? With me so far? David? Okay. By the way, if you're ever in a restaurant, do not snap at the waiters and waitresses. They do not like that. Okay. Just, worldly information. So we can use a ray diagram to explain the formation of the image. Okay? So first, we draw the lens here with our horizontal axis. So straight line right through the center. Okay? Then we mark the positions of the principal focuses, F. So there's one on this side, one on that side. So there's principal focus on both sides of the lens, and they're both going to be the same distance from the lens. So if this was 2 centimeters, this one's also 2 centimeters. Okay? Now we have our object, O, and we draw this line straight up. This line should meet with the top of the lens. Okay, so that arrow we put on top should meet with the top of the lens. Then we draw our first ray from the top of our arrow here through the center of our lens, and then we just keep going. Okay? Then the second one goes parallel to the horizontal across to the top of our lens and through the focal point. So wherever we put the focus point, it will go through that point. And where these two meet, that will be where your new image would show up. Okay? So this would be our new image. Does that make sense? How to draw our ray diagram? Not really? Where did I lose you? This line, so like I said, you draw this arrow up, which should be about the same height as your lens here. It will always go from the top through the center of your lens, every time. The first one will always do that. And then the second one will start at the same point, but will go parallel to the top, and then you put it, when you stop in the middle, you put it through the focal point. So if I had, use my ruler as an example. I stop in the middle, and I want to make sure that that line always goes through the center there. So wherever you put this focal point, that's where the second one has to pass through. So depending on where the object is, whether the object is here, on this side of the focal point, and there's another one where it's even farther, this image will be in different places. And sometimes it might even be right side up, sometimes it might be a virtual image over here. It all depends on where the focal point is compared to where the object is. So if you remember back to the very first lesson where we started light, I talked about the 3 different situations where the object is to the focal point and what the image would look like. So if you look back in your notes or in the textbook, you'll find that information there as well. So now what we can do is we're going to draw one of these ray diagrams. So, So, like it says on the handout there, the focus point needs to be 5 units from the center of the lens. So each little square is 1 unit, just in case you're confused. The object I want to be 9 units away from the center of the lens, which means it should have the lens, focal point, object on the other side of it. Okay? 5 units from the center of the lens. So each square is 1 unit. So follow the same 2 steps that I did here, right? You'll have your focal point, your object. First line goes through the center of the lens. Second line parallel to the top, then through your focal point on the other side. you to draw the arrows of the object that's going up. That's roughly going to be. Now first, you should draw. No, please.
Can you please?
So from the top to the center, yeah, and just draw it all the way to the end. Draw it all the way. It bends down, it has to this. Okay, looks like everyone's fine with this. So here's basically what it should look like. On mine, obviously you can't see the grid quite so much, but our focal points on both sides, 5 units away from the center. My object is 9 units away. I drew my line. One line parallel to the top through the focal point, and one line through the center, and it meets over here, which was about 11, I think it was about 11 squares away, roughly 11 and a half or so. Okay. So, any questions about that? No. And that is all. So,